What's up, guys? We are back again with day 4 of Advent of Code 2023. What we've got for you today is probably the easiest challenge so far. We're given input that looks like this, and in part 1, we're told that the elf believes that the left-hand side represent winning numbers. This is basically some kind of lottery or scratch-off type thing. So he thinks that the left-hand side are winning numbers, the right-hand side are our numbers. So all we have to do is check how many of our numbers are winning numbers on the left. And then there's a simple scoring function where the first one gives you 1 point, and then you double your points for every additional one after that. So with that pretty simple input and simple rule set, we can hop over and look at the code. As I was saying, nothing too complicated today, so you'll see I've got a print statement here at the top, so you'll be able to see what each of the lines looks like, and then the score I assign it. At the top, even though you don't have to initialize variables before you use them for the first time in AWK, something to keep in mind is that they do persist between each line. So I'm not sure I've said this explicitly yet, but even though AWK in general has a pattern and an action, and the action is enclosed in curly braces, if you leave out the pattern, it gets executed on every line. So when you see this, we're going to print every line, and then we need to reset our variables before we start processing each line. So today everything is white space delimited, so we don't have a begin block where we're messing with the field separator or anything like that. We just jump right into our for loop. We skip, if you'll remember from the sample, it says game, or whatever it says, and a number. So we skip those two and jump straight into processing the other stuff. The first thing we check for is if the field is a pipe, because if it's a pipe, we need to change how we're processing it. Again, on the left side, we're processing so-called winning numbers, and on the right-hand side, we're checking our numbers against the winning numbers. So as soon as we find that, we just hit check. We don't technically have to continue because the other conditions aren't going to hold on that line, so we could make this a little shorter if we wanted, but I think it's safe to say to continue here. And as you can see here, I'm saying if not check, so we haven't hit the pipe yet, then I'm just putting things into this found array. And yeah, I guess I haven't said it yet, but delete, you can call delete on an array to reset it as well. So that's what we're doing up here. And we're actually taking advantage of what I mentioned yesterday, where simply indexing into an array without actually setting anything in it does create the entry. So I'm going to use this immediately on the next line to check if the index has been found. So this is one way that you can basically use aux arrays as sets. So yeah, I probably would use like a hash set in Rust. And then this is our other case. So this was the if not check. And then once we find the pipe, we're in our numbers. We check if the number is in found, if it was one of the winning numbers, and if it is, we count up our winning numbers. And then at the end of the line, we assign our score using this overcomplicated formula. But basically, if n is greater than 0, we just raise 2 to the power of n minus 1, because I think we increment it 1 extra time, basically. And this will give us our score. And then, yeah, we just add that to the total, and I also print the score. So I'll go ahead and run this just so you can see what comes out. And I'm running it on the sample, which should make it a little easier to tell what's going on. So this is our first line. You get an 8 because 3 of our numbers, I believe, are in the winning numbers. And so on. So that gives you the right answer for part 1. Now, to get into part 2, I just had to go ahead and pull up the instructions because they're kind of confusing, and I figured I would mess it up if I didn't have it in front of me. So this time, as is often the case, we're told to reinterpret our input file. It's no longer winning numbers and our numbers. Now we find out that instead of getting points, like we thought in part 1, we actually get additional scratch cards. So each time, so we take one of these lines, and our number of winning numbers becomes the number of additional cards we get. So in this case, I think we find 3 winning numbers, and that means that we get an extra card 2, an extra card 3, and an extra card 4. And then for each of these, we can recurse basically, and each of these cards is going to give us some number, and we have to repeat that for each of the additional cards that we get. And so you'll see, if you read the description down here, oh, card 1 actually has 4 matching numbers, of course. We win 1 copy of these cards. Card 2 has 2 matching numbers, so you get copies of this copy of card 2, and so on and so on. So go check these out if you're really curious, but that's the general idea. Hopping back to the code, you'll see that it actually hasn't changed a lot. So one very minor change is that I moved this delete found onto the same line as the others with an extra semicolon, and I added a little comment, which is kind of superfluous now because I already explained it in the video. But you'll see that the main structure of our code is basically the same. We're still checking for the pipe. We've got the check. We've got check, found. Yeah, this whole section is exactly the same. Now, I saw a lot of people online talking about their recursive solutions or their, their code taking forever because they were running all these loops and stuff. And I thought we were going to run into the same thing, I'll be honest, when I first read it. But before too long, it became clear to me that we could actually do this just in a single pass. And all you really have to do is you keep this list of cards. Each time you get another card, you increment the count. So the initial increment will be the first card you get, or the first time, or when you actually visit the card. There we go. And then however many matches you found, you just iterate over that, which, if you'll remember from part 1, is what our n was. So you just decrement that back to 0 and add 1, or add your number of cards to the nr plus n position. So basically you're incrementing all of the future cards by the number of occurrences of the current card. And then you can do it in one pass. At the very end, we just add them all up, which I think I realized after the challenge that this could be part of our single pass as well. But anyway, I did it this way. Or no, I think you do have to do this at the end. But in any case, this is the core of the algorithm. At the end, we just add everything up and we print it out. Of course, we see the re-emergence of our max function. For some reason, apparently I didn't even use that. So anyway, we've covered everything. Plus we got a bonus max function. So as always, thanks for watching, and I'll see you guys tomorrow with day 5.